like number 9.
Okay. I mean, you said the whole review will be on there. It's gonna be long if it is, so. Today we were asking questions and he was like, I just don't get how you guys like. He was doing that whole thing.
All right. Today we're gonna learn how resistors are wired in series and parallel. Know the difference, what measurements are the same in series and circuit, series and parallel, and know which ones are summative, and be able to calculate total resistance when things are wired in series and parallel. Now, in order to, I've got this analogy that uses a water tower. However, I've realized that a lot of people don't know how water towers work and why we do. Okay? So it seems kind of ridiculous, expensive to post a swimming size container, a swimming pool size container of water 5 stories above everything else just to like advertise your town. Here's the point. So if you're on a well, you don't use these. You have your own pump and a pressure tank to give you pressure. If you're on city water, then you are using the water tower. If we didn't have a water tower, we'd have to have some crazy amount of pumps to get everybody to have the same water power pressure. We have in the morning and in the evening, that's when we have a lot of demand on the water. Everybody's taking a shower, which would require a lot of pumps. We have a water tower to provide that pressure for everybody regardless. So water pressure is determined by depth. If you swim deeper into a pool, you have more water pressure. Okay, so the higher we elevate our water tower, the greater our pressure is going to be. So if you were swimming here, this would be a crazy amount of pressure. Even though it's skinny, it doesn't matter. It's all about the depth. So the higher you put this, the more pressure is going to be, more motivation to flow. You good with that? And so the way we work this is just in real life. You have a single pump that's always filling the water tower. In the morning, everybody takes a shower, and it drops the water level. And then the pump fills it up throughout the day, and then at night, people take showers, drops the water, and then over the night, that single pump still continues to fill it up. So you have one pump able to provide the water pressure with conjunction of the water tower. Good with that? So this is our battery. This provides the water pressure. Okay, and it's a constant pressure. Okay, if we put a hole in that and then put kinks in this hose, which provides resistance, you get a certain amount of water coming out per second. That's your current. You okay with that? If we were to put another kink, what do you think would happen to the current? If we get a decrease, be less. Okay. These kinks are in series with each other, one right after the other. So your total resistance, your total resistance in series, you're just going to add them up. Does that match what you just experienced in your lab? Are we okay with that? Okay. All right. What do you say? Did I get an E? Okay, that corresponded to what you just measured, like around 0.1 amps all the way around, didn't matter where you measured it. Okay, factoid. Okay, memorize this. The current at every spot in the series circuit is identical with every other spot. Okay, so the current is equal in a series circuit. Okay, good. Okay. Have a conversation. Tell them why you think so. Correct answer is C. But wait, I just thought you said the current stays the same. It's all the same. How did? Okay, making some numbers up here. The current here, 3 amps. Current here, 3 amps. I'm making this up. 3 amps. The current at every spot along here is the same. If you change the circuit, then you're going to change the full resistance. And the current here is going to be, making these numbers up, 5 amps. 5 amps. 5 amps. 5 amps. So it doesn't matter. So what the factoid is, the current at every spot along the series circuit is the same compared to all other spots. But if you change the circuit, you're going to change the current. It's going to be the same at all points. That's what that memorized thing is. The current is the same in the series circuit. That's what that means. Okay? Good? Have a conversation.
Yeah, if you add up all the resistance, like you go to the 4, doesn't matter. It's 12 and a half. So then, put in 23, that's like.
Correct answer is. Okay. If your circuit looked like this, just the 4 ohm resistor, the correct answer would be B. Okay, but it's not. It's hooked up. There's the 3 ohm, the 5 ohm, and the 4 ohm are all hooked up to the 24 volt battery. So your total resistance is going to be what? 12. Okay? So when you do Ohm's law, make sure that you are looking like everything agrees, like your total voltage, your total current, your total resistance. Okay, so the correct answer is A. because you have 12 ohms here. You have 24 volts here. You're looking for your total current. Good? Okay, I'm looking for the voltage drop, the potential drop across this guy. Tell your neighbor what you think. Okay. Correct answer is, you notice a series circuit. So you have 2 amps going through this guy, 2 amps going through this guy, 2 amps going through this guy. Yes? Okay. Now, you can apply Ohm's law to individuals, resistors as well. Okay? So make sure these all agree. Okay? So we have 2 amps going through this. There's a 4 ohm resistor. So our voltage drop across this is 8 volts. See how I did that? So you can apply Ohm's law to the whole thing or an individual. Just make sure all your subscripts, all these variables are corresponding to total or individual. Good? Tell your neighbor. Correct answer is 5 ohms. Okay? You have an 8 volt drop here, a 10 volt drop here, and a 6 volt drop here. Got that? Okay? Last thing, how does this demonstrate Kirchhoff's loop rule? Okay, so check it out. Voltage gain equals voltage drop. .24 volt gain. 6 plus 10 plus 8. Check this out, last thing. Here's my analogy. It's called chutes and ladders. You have a 24 volt gain. This is given energy. This is the ladder. Climb it up. And then you go across the wire, and then you have a 6 volt drop. This is your chute or your slide. 6 volt drop. Then you have another wire. And then you have a 10 volt drop. And then you have an 8 volt drop. And now you're back to where you started. Okay? So your voltage gain is equal to the sum of your voltage drops. Good with that? Okay. Your homework tonight is to finish page 2 of the lab, if you haven't already. Okay?